Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome you all at online chemistry class. Chapter number 2, atomic structure. The topic of today's lecture is X-rays. Lecture number 7, B part. X-rays and atomic number. Discovery of X-rays. Students, if you remember, we discovered the cathode rays in the discharge tube. We discovered the positive rays in the discharge tube, and now we are going to discover the X-rays in the same discharge tube. Okay, that is the glass tube which containing the cathode, which containing the anode and connected with the source of battery or electricity. ओके सेम वही डिस्चार्ज ट्यूब है जिसमें हमने कैथोड रेस को डिस्कवर किया था, जिसमें हमने पॉजिटिव रेस को डिस्कवर किया था. सिर्फ हमारे पास जो डिफरेंस है इस डिस्चार्ज ट्यूब के अंदर वो ये है कि हमने यहाँ पर जो एनोड इस्तेमाल किया है वो एक हैवी मेटल का होता है. ठीक है, हैवी मेटल का एनोड इसके अंदर इस्तेमाल किया जाता है. नाउ द इंट्रोडक्शन अबाउट द डिस्कवरी ऑफ द एक्सरेज. जिस साइंटिस्ट ने इसको डिस्कवर किया था, हिज नेम वाज द W.K. रॉन्टगन. Nobel Prize holder discovered that when high energy about 5000 to the 10,000 voltage cathode rays are focused on a metal target used as anode in the Crookes discharge tube, highly penetrating radiations are produced. Roentgen called them the X-rays. X-rays mean unknown, and sometimes these rays are known as the Roentgen rays, as the Roentgen is actually the name of the scientist. Okay students, अब आप देख सकते हैं इस डायग्राम के अंदर कि हमारे पास डिफरेंस सिर्फ क्या है, सेम वही डिस्चार्ज ट्यूब है, सिर्फ इसके अंदर चेंज हमने ये किया है कि यहाँ हमने हैवी मेटल टारगेट एज अ एनोड इस्तेमाल किया है. यहाँ पे जो आपको मेटल शो किया जा रहा है दैट इज एक्चुअली द कॉपर मेटल, एंड यहाँ पे हमारे पास कैथोड रेज आके इस पे स्ट्राइक कर रही है. नाउ production of X-rays. What is the reason for the production of X-rays? When the electrons in the cathode rays hit the anode, that is actually the from the that may be any heavy metal, it knock out the electron from the inner shell of the atom, which unstable the electronic configuration. This produce a metal ion with an electron missing from inner orbital, and then an electron from the orbital of the higher energy drop into the half-filled orbital and photon is emitted, which produce the electromagnetic radiation in the X-rays region. You got it students? Production of X-rays हमारे पास किस तरह से हो रही होती हैं? Properties of the X-rays. These rays have the ability to penetrate paper, rubber, metal, glass and human flesh. In human flesh, that's why we use it in the medical field. X-rays are electromagnetic radiations of the very high frequency. They have very short wavelength. The frequency or wavelength of the X-rays depend upon the target material which we use as the anode, and X-rays play important role in the medical field. Now, what is the relationship between the X-rays and atomic number? First of all, you should know what is atomic number. The number of proton in the nucleus of an atom is called the atomic number. It is denoted by the symbol Z, and different elements having the different atomic numbers. Now, what is the relationship between the X-rays and atomic number? In 1913, a scientist, his name was Henry Moseley. He observed that the metal target of different 38 elements emit X-rays of that different frequency. He established a relationship between the frequency of the X-rays and the positive charge of the nucleus of an atom target. According to the scientists, the frequency of the X-rays increase with increasing the number of proton in the nucleus of target element. Or you can say, जैसे जैसे हम लोग मेटल जो हम लोग यूज़ कर रहे हैं, अगर हम उसका एटॉमिक नंबर इंक्रीज़ करते जाएंगे तो हमारे पास जो एक्सरेज है उसकी फ्रीक्वेंसी भी इंक्रीज़ होती जाएगी. सो वी कैन से that there is a direct relationship between the atomic number and the frequency of the X-rays. Okay, the relationship between the X-rays and atomic number is actually the direct relationship. जैसे जैसे हम atomic number increase करते जाएंगे हमारे पास X-rays की frequency भी increase होती जाएगी. Moseley conclusion that the spectral lines could be classified into two distinct groups, that is the shorter wavelength called the K series and the longer wavelength are called the L series. If the target element is of the higher atomic number, the wavelength of the X-rays become the shorter. So we can say that the atomic number is inversely proportional to the wavelength. Okay, if we increasing the atomic number of the target element, what is the target element? Target element we use as a anode in the discharge tube. If the target element is of the higher atomic number, the wavelength of the X-rays become the shorter. There would be a you can say inverse relationship. So the relationship between the frequency and atomic number is given by this mathematical expression, where A and B are called the constant quantities. This is called the Moseley law, which state that the frequency of a spectral line in X-rays spectrum varies as the square of the atomic number of an element emitting it. So we can say there is actually the direct relationship between the frequency and the atomic number. Now the production of the X-rays. Here we have a supporting video. I'm sure आपको यहाँ supporting video से आपको बहुत अच्छे तरीके से X-rays की production समझ आ जाएगी.
Production of X-rays. The lab setup shown here was designed by Coolidge, and hence it is called Coolidge tube. It contains a highly evacuated glass bulb containing a cathode, which is a tungsten filament, and anode, which is a target made up of metal of high atomic weight. The pressure inside the bulb is maintained at 10 to the power of -6 millimeters mercury. When the cathode is heated by passing a current through it from a low-tension battery, it emits cathode rays. These rays are nothing but electrons. The filament is surrounded by a molybdenum cylinder, which is kept at a negative potential to the filament. This repels the electrons further, and hence the electrons form a fine pencil beam at the center of the cylinder. This pencil beam is also accelerated by the cylinder towards the target. The target is made up of a copper block in which a piece of tungsten or molybdenum is fixed. High thermal conductivity is used to carry away the heat generated to the cooling setup. Here we use copper, which is a good conductor of heat and can take the heat away from the molybdenum metal towards the water cooling system. The target is also tilted at an angle of 45 degrees, causing the electrons to hit at an angle. This will produce the X-rays almost perpendicular to the electron beam. A very high potential of 20 kV is applied between the source and the target. Due to the high potential difference, the electrons are accelerated towards the anode and it hits the metal. When it hits, the kinetic energy is transferred to produce X-rays. The intensity of the X-rays depends on the number of electrons striking the metal target. So, if we can increase the rate of electrons emitted by the filament by increasing the current flowing through the filament, then we can increase the intensity of the X-rays.
Thank you so much, students. Wish you all the best. Allah Hafiz.